Alright, so maximum value sum by placing three rooks part 2. I did solve the part 1, so if you haven't checked that out, you can check that out because I'm going to reuse the most of the code in part 2 as well. And I'm going to solve it, but there might be better solutions, but this will pass. So basically, this is what was the part 1. So the question states that we are given a chessboard and we are asked to place three rooks, and each rook should be placed such that no other rooks are in the same row or the same column, because they can attack each other in that case. So I have to place it in a way that they can't attack each other. And after placing, I want to find the positions such that the values at which they are placed will sum up to the maximum value that can be possible. This is what the question states. And how we did solve it is by finding the maximum three values of each row. So this row will give me 1, 1, 1. This row will give me 1, minus 3, 1. This row will give me 1, 1, 2. So that's how we did solve it, and we found that max 3, and we used a priority queue, and that took a time complexity of O of m cross n. This is going to be the same thing for part 2 as well, because we can't do anything better than this one, but we can make this better. And this is where we did, brute force on the uh, max 3 array that we formed. Basically, uh, we took m cube time complexity, but this can be made better using a concept that I think you already know, but not with three values, but usually with two values. That is, we sometimes in questions we store two values, right? First maximum and second maximum. And in the question, it's somewhere mentioned that we can't reuse the same value that we have reused. You know, I'm not sure what question, but you get it right. The questions where we asked to use the second maximum value because the first maximum has already been used. So the same concept can be applied here, because if we choose a row like this, if we choose a row here, it'll be going till m, and we choose a value in that uh, from that row. So every row is having three values. Row one, first value, second value, third value. Similarly, suppose there are four rows, and these are the first, second, and third values that that represent the maximum three values for this row. Similarly, this one, this one, this one. Now what we are doing here is we are doing a brute force here. We are selecting this, and then we are selecting. Suppose this one we can't select because it's in the same. I mean, it depends. I don't have the column here, but I am having the column as well, so that I can validate that I'm not selecting the same column. So we are doing a brute force here, and that's going to take a time complexity of m cube 27 3 cube. But what we can do is, apart from this, if I select this value, then what essentially I need is two other values which are from this lot, because I have selected this value from this row. I can't select any other value from this row. So I need two more values from this, such that the column is different, right? So every variable is having a column index as well along with its value. So I can validate that. Suppose this is the one that I select, or suppose this is the one that I select. This is the first one, and this is the second one. Now I need the same thing for this lot. Because I've selected this row, now I can't reselect it. This is the lot that is remaining. So I need the maximum. Essentially, I am doing what is I am getting 4 max values. Why 4? Because if the column is same, then I can use the extra value that I have chosen, right? Like I showed you for the two variables, first max and second max. But since I need three values here, three rooks needs to be placed, right? So I need four maximum values. Because of scenarios where the column is same, then I can select the remaining values that I have. So that's what we are going to do here. Essentially, I'm going to select a value and find, let me write the steps here. Select a row in which select a value. Now, at this point, find four maximum values from other columns, from other rows and other columns. Right, so I have selected a row and I have a value and a column in this. So I have a row and a column by the end. Now I need to find four maximum values from the other rows and other columns, and then I can do a brute force on this four max values. Okay. That's what we are going to do. Let me uh, take this outside, take this code, paste it here, and essentially I am updating this part, which is the brute force part, and all this remains the same. Alright, so I have max 3. Let's get into the code. I will be selecting a row. So I have number of rows m. So from max 3, I'm selecting a row. That will be this part. This will give me, or probably let me call this row 1. Row 1, row 1. Now I have a value, that is value 1, which is max 3. So this is a vector. So if you haven't watched my the part 1 video, then highly suggested that you go and watch that. So max 3 is going to have a pair for this row. It's going to have a pair from which the first is the value. So actually, so there are three values, right? So in which I select a value. So I have to get the second down to the second index as well. That is nothing but j. J is less than 3. J plus only 3 values exist in each row. Now I get the value and the column. Value will be max 3 of row 1 and j dot first. Similarly, second, this is the column. Now that I have selected it, I need the max 4 values. I will use the same concept that I did here. So I'm going to create a max heap, min heap and a vector. So I'm going to do the same thing that I did here. I need uh, a vector of int is fine. I'm going to use that. So I'm going to change this to a vector of int. I think this is good, and I'll call this max 4 amount. Uh, yeah, I'll call this max 4. Alright, and the size I don't need it right now. The size will be 4 by the way. So I'm going to do a brute force now. Not brute force, I mean traverse all the rows except this one, the one that I've selected. That is nothing but row 2 is equal to 0, row 2 less than n, row 2 plus plus, and the same thing goes here, but let me take instead of jk, right? And as of now, I will get the second value and the second column. Alright, but here itself I'll check if row 2 is equal to row 1. In that case, please continue, because I need to find the 4 max values from other rows, right? So I get the column, and that is nothing but max 3 of row 2 and k dot first. Same goes for column 2, but second. And at this point, if column, so I also need it from other columns. So column 1, if it's equal to column 2, in that case please continue. Otherwise, now I'll fill the min heap dot push. I'll fill 3 values because I'll need the row and column as well by the end. So I will fill it with the value 1 or value 2, the row 2, and the column 2. Alright, and I'll check if min heap dot size is greater than 4, then please pop the same thing that we did here, but for 4 values now. So by the end I will have what I need, that is, now I'm ready to fill max 4. So that is nothing but this same thing, okay? So I can even copy paste it, but yeah. So I'll be filling max 4. This is just a vector with the min heap value as I go, and I'll pop min heap. By the end I will have 4 values in max 4. So now this is over, and at this point I'll do a brute force with the 4 values that I have. In this 4 values I have both the rows, column, and the value, right? So I can still validate things. Right now I am in this, so I have row 1 access and column 1 access. I need to calculate the same thing for the second and third value in this four values. Alright, so I will just do brute force. That is nothing but L equal to 0, L less than, 3, because four values, so I'll use one less. I mean, I can do it in multiple ways. Do it in this way for int, uh, let me take p 0, p less than 4. At this point, I'll take 4, p plus plus. Actually, this will start with L plus 1 on that. Alright, so this is L, this is p, and at this point itself, I'll get few things. That is column 2, row 2, value 2. Just don't get confused with this column 2 and this column 2. This was just for finding the max 4 values, right? And this value 2 was the same thing. And this row 2 was the same thing for max 4 values. I've sorted those, I've processed those. Now it's time to find the real row 2 and real column 2. So that will be nothing but max 4 of L of 2. So I'm storing, I think, the third element as column, and the same goes for row, but for the first element or first position, and the same goes for value, but for the 0th position. At this point, I'll check if column 2 is equal to column 1, or row 2 is equal to row 1. In that case, please continue, and I'll get the same things for this lot, but these will be for third value, third row. So column 3, row 3, value 3. This will be P, this will be P, this will be P, and this will be checking against. So now that I have checked it for column 1 and column 2, they are equal. I don't need to check it for column 3 and again column 1 with column 3. So I'll just check for column 2 and column 3, and row 2 and row 3. So these are equal. We'll continue. Now comes the part where I will update my answer with the max answer, comma val1 plus val2 plus val3. At this point, this might go slower, so make sure this is long, and I think we are good. We'll talk about the time complexity, but let's see if this works. This is push. My bad. This is vector now. So let me do it vector of index of pair, because I need 3 values. So I think this is good. Let's see now. MST semicolon. Okay, it does work. See if it gets submitted. Right, it does get submitted. There might be better ways, but let's see the time complexity of this part. This will be m cross n, the same thing, but this one is, I'm selecting a row, so m. I'm selecting a value, so 3. I'm selecting a inside every row and every value. For that, I am selecting all the other rows and all the other values. So again, the same thing, M3, and finally, I am doing it for brute force for the four values that I get. So it's actually not 4 cross 4, but 4 cross 3. So essentially, this will be nothing but m square, I believe, and into 27 into 4, something around 107 or 108, something like that. That will be constant, so it will essentially be m square. And the previous method was O of m cube. That's why it was failing. This was O of m cube, and this is O of n square. O of m square. Right? Thanks, guys.